solute. If you dissolve say 10 particles of acetic acid in benzene, let's say 5 particles are associated, so that is your number of moles of solute associated, right? If 5 particles of acetic acid are associated, here it's 5 and total number of moles of solute was 10, right? So this is represented by alpha, degree of dissociation. I'm sorry, degree of association in this case. So now let's take a generic example where n particles of A, right, are associating, right, to give where n particles of A are associating to form this AN, right, like this. It will form this n particles will associate to form AN, right? Now suppose 1 mole of solute is taken, right? 1 mole of solute is dissolved in the solvent. So after association, the concentration of species after this association has occurred, right? Let's calculate the concentration of these associated molecules and these unassociated molecules, right? So after association, concentration of species would be the concentration of this molecule, associated molecules, would be alpha upon n. Why n? Because alpha is the degree of association and n is the number of molecules associated, right? Total number of molecules associated, this number of this degree of association divided by number of molecules associated is your concentration of A. Similarly, concentration of this one, this is the concentration of associated molecules, and the concentration of unassociated molecules would be 1 minus alpha, because here the alpha is the degree of association, right? So alpha is the degree of association, so the unassociated molecules would be 1 minus alpha, right? Because 1 mole of we have already taken 1 mole of solute. So total moles after association would be, total number of moles after association would be moles, associated moles plus unassociated moles, right? So that is associated moles, which is alpha upon n, and unassociated moles, which is 1 minus alpha, right? So if you calculate this, the value of I would be 1 minus alpha upon n, this, right? And this will come to be alpha is equals to 1 minus I upon 1 minus 1 upon n. This is the relationship between degree of association and Van 't Hoff factor. And when no association will takes place, right, here alpha is 0, degree of association would be 0, then in that case I would be equal to 1 when no association takes place. Van 't Hoff factor is 1. If association is complete, that is when alpha is equals to 1, here when alpha is equals to 1, all moles of solute, the complete solute is associated, in that case alpha would be equal to 1. Then I is equals to, if you put here alpha is equals to 1, then you will get I is equals to 1 upon n, right? So this is the derivation, and this is important, this relation is important between alpha, degree of association, and n, the number of molecules associated. From here you can calculate the number of molecules associated, right, if you are given the Van 't Hoff factor. Similarly, the degree of dissociation is, like we have discussed the case of dissociation, degree of dissociation would be number of moles of solute dissociated upon number of moles of solute taken, right? So total moles of solute taken and the number of moles that have undergone dissociation. So considering 1 mole of solute in solvent like this, like we have done in this case, suppose molecules dissociated to give n ions, right? Suppose 1 molecule dissociated to give n number of ions. Number of moles of ions would be n alpha, where alpha is the degree of dissociation. So number of moles of solute undissociated would be, alpha is the degree of dissociation, so moles that are undissociated would be 1 minus alpha, right? So total moles n alpha plus 1 minus alpha, which will come out to be the relationship in case of dissociation between Van 't Hoff factor, this is Van 't Hoff factor, and degree of dissociation would be this, from where you can calculate the number of ions that are dissociated, right, or the alpha, the degree of dissociation when I is given to you, right. So I hope all this is clear to you. Thanks.